When you are looking at the graphs for system of equations, there are three different cases that will come up, three different possibilities. The first possibility is that on your graph, there are two lines somewhere, anywhere, that do cross somewhere. They do intersect, which means that that system has one and only one solution because it crosses in one place. What would happen though if those two random lines, wherever they're at on the graph, were parallel? Pretend like those scribbles are parallel. I realize that one got a little curvy. Do those lines have a point in common? No. Do those lines cross anywhere? No. Which means the system actually has no solutions. The next possibility, the third possibility, is that there are two lines that weirdly, oddly enough, are actually exactly the same. Every point that is on one line is also on the other. They share every single point that exists, which means they share an infinite number of points, which means that system has infinite solutions. Those are your three cases. Either the system has one solution, the system has no solutions, or the system has infinite solutions. Let's look at that first or not the first IXL, but the next one and see what we're looking at there. Y equals x plus 7 and y equals x plus 7. Unless you are 100% confident in your graphing skills, I would check what the lines look like in the Desmos graphing calculator in order to make sure that you're going to graph them correctly. Let's look at that red one first. Y equals x plus 7 means that that line should start at 7. Yes, it does. And then that slope is 1 over 1. So when you make another point, you'll go up 1 over 1, up 1 over 1. In order to switch and graph the second line, ooh, that's kind of weird, Mrs. Coth. I'm pretty sure that's the exact same line. You start at 7, and then you go up 1 over 1, up 1 over 1. Those look the same. Let's go out a little bit. Do you see how when I select and unselect this line, those lines are actually right on top of each other? Which one of those three cases is it? Is that a system that has one solution where they cross once? Nope. Is that a case where there are no solutions, where they're parallel? Nope. Or is that a case where there are infinite solutions because those lines are actually right on top of each other? The first thing IXL wants you to do is graph them. So we're going to start at 7 and go up 1 over 1. You have to go down here and switch to the other line. Put another point at 7, another one up 1 over 1. And then if you look really closely, IXL does show you those two lines right on top of each other. How many solutions does the system of equation have? Infinitely many is what we're going to pick. Y equals 1/2 x plus 3 should start at 3, and it should go up 1 over 2. Now we have to switch to the other line. Y equals 1. There's no x, so that should be a horizontal line. If I were you and I didn't want to mess this IXL up, I would go over to Desmos and I would take the time to type those in just to make sure that I did them correctly. Because if you mess up on graphing the lines, IXL is going to count you wrong. It's going to make you do the problem again, and you're going to get frustrated with that. So let's make sure that that looks like ours. And yes, it does. These two lines cross right here, which means that this system has one solution because it crosses in one place. Y equals 3x plus 6. So we start at 6, up 3 over 1. Y equals 3 is just a horizontal line. We have to switch down to that other line. 3, and then straight across. They do cross right there in that one place, so the system has one solution. Graph these ones. This starts at 3, and then down 3 over 2. 1, 2, 3 over 2. That one starts at -5 and goes up. Oh, I forgot to switch. -5, and then what was it? 1 over 2. So up 1 over 2. They do cross in just one place, so one solution. That's all you need to do here in order to do this IXL. My suggestion to you would be to type those 2 lines into the Desmos graphing calculator to make sure that your graph is correct. You have a way to check your answer if you take the time to do so.